So we have taken a look at using the law of sines to solve triangles. Next we're going to look at this one, solving applied problems, and then we will also be looking at how to find area using the sine function. Tomorrow we'll get to objective 2. So, applied problems. Two fire lookout stations are 20 miles apart, with station B directly east of station A. Both stations spot a fire on a mountain to the north. The bearing from the station A to the fire is north 50 degrees east. That means 50 degrees east of north. Bearing from station B to the fire is north 36 degrees west. That means 36 degrees west of north. How far to the nearest tenth of a mile is the fire from station A? So what I'm going to do is I'm going to start by drawing a picture of the situation. So there's my mountain to the north there. And unfortunately, it is on fire. So, there are some stations. Here is station A, right here. And it says station B is directly east of station A. And that they are 20 miles apart. Both stations spot that fire and they communicate their bearings. Station A looks at the fire and says that it is north 50 degrees east. That's 50 degrees east of north. So north is this direction. So 50 degrees towards the east of that would be towards east 50 degrees. That line is 50 degrees east of north is what that means. And then station B says that they see the fire at a bearing of north 36 degrees west. So you can see this direction would be north. 36 degrees west of north would be towards west, which would be this direction, 36 degrees. And that's the information that we have. So, how far the nearest tenth of a mile is the fire from station A? So I'm trying to find this side length right here. And because that's opposite angle B, I will call that side length B. That's what I'm trying to find. So if you look at this triangle made between the fire station A and station B, I only know one side length and none of the angles. But I can easily find these two angles because you'll notice since A and B are directly east of each other, this right here is a 90-degree angle. And you can see that since that's 50 degrees, 90 minus 50 is 40, so I know that this angle right here is 40 degrees. And then same thing here. This is a right angle, so I can do 90 minus 36 to get that this angle is 54 degrees. So this angle from there to there is 54 degrees. I then can subtract both of those from 180 to get that this angle is 86 degrees. And you can see I now know all three angles and one of the side lengths, which means I can use the law of sines to find that missing side length there. So I set up the law of sines. I want to find that side length B, so I say side length B over the sine of the opposite angle, that's sine of 54 degrees, is equal to, and now I'm going to choose the side length that I know, 20 over the sine of the angle opposite, that side length of 20 is 86 degrees. And then I can solve this the same way I've solved all these other ones. Multiply both sides by the sine of 54 degrees. That'll cancel. And then you just use your calculator, type it in. 20 times the sine of 54 divided by the sine of 86, which I've already done. You can see I get 16.2. So side length B is approximately 16.2, which means that station A here from the fire is about 16.2 miles away. All right, next. Oh, here's that same diagram. I don't know, I like mine a little better, but that's pretty good too, I guess. Next, we're going to move on to learning another formula today. And this is a formula that will help us find the area of triangles using the sine function. And this is a formula that's going to use we're going to use when we know two sides and an angle in between those two sides, side, angle, side. So here's what that means. Like, let's say I have a triangle here. I'm going to call it triangle A, B, C. So this is side length A, this is side length B, and this is side length C. And let's say the two sides that I know are these two sides. Let's say I know that side and their included angle, and let's say I know that angle. So given those three measurements, can I find the area of this triangle? Well, this formula we're going to learn is based on this old formula that we know that the area of a triangle is 1/2 times the base times the height. Now it just so happens that in this triangle my base is already called B, so that's good right there. I already know that measurement, so like all I have to do is plug that number that I know right in there. The problem is though that I don't know the height of this triangle. So the height of the triangle is this right here. It's the line from the top that makes a right angle with the base. So how can I find this height? Well, what I'm going to do is I'm going to use these other two measurements to find the height. And the way I do that is I look at this right triangle that's made right here. Because the sine of this angle right here will be equal to the opposite of that angle, which is called the height of the triangle, divided by the hypotenuse of this right triangle, which is side length C. And then what I'm going to do is I'm going to solve that for h by multiplying both sides by c. And that tells me that side length c times the sine of angle A is equal to the height. And what I'm going to do is I'm going to say, okay, since the height equals side length c times the sine of A, I'm going to plug that into this formula in place of height, because this is a way to calculate the height. And when I do that, I get that the area of this triangle is equal to 1/2 times side length B, the base, times side length C, times the sine of angle A, because that's how you can find the height. And that gives me this formula for the area of a triangle, if you know two sides and their included angle. Now basically there are three versions of this formula, because the side lengths you know won't always be called B and C and be called angle A. Like if you know side length A and B, then the formula would be, you know, side length A times side length B times the sine of the angle in between those two would be angle C. Or the area is equal to 1/2 of, let's say you know side lengths A and C, then the included angle you would need to know is angle B. So basically there's three kind of versions of the same formula, and really your formula might not even be called ABC, it might be called DEF, in which case, you know, the side lengths you know go right there and there, and the angle in between them goes right there. I don't know why we use K for area. Basically, the letter A was already taken for angle A, so we use K for area. Let's take a look at how this works. So find the area of triangle ABC if this is what we know. So again, as I always do, I'm going to draw what I know. So here's angle or triangle ABC. Side length A is 13, side length C is 8, and angle B is 130. So all I need to do is plug it into the formula for area. K is 1/2 of the sides I know this time are A and C, and the angle in between them is angle B. So I plug in 1/2 times side length A is 8 times side length C, or sorry, that was 13, and side length C is 8 times the sine of 130 degrees. You can just type that all into your calculator and get 39.8 centimeters squared is our units, and there's our answer to the nearest tenth. So that's it for today's lesson. You can rewatch this video as many times as you want and then do your homework.